This is part 2 of differential equation applications. In this video, we'll look at some word problems, some examples dealing with exponential growth and exponential decay. So the first example says that a radioactive particle delays at a rate that is going to be proportional to itself. So meaning that it's going to follow the differential equation we talked about in the first video, which happens to be this one. So we know that it's going to have a solution that looks just like this. So we can assume that the solution to this is going to be this based on the previous video that we saw. It tells us that the half-life is 65 days, and this is going to be really crucial to help us find the K, the constant of proportionality. And so for part A, it says that a sample starts with 300 milligrams. How much will remain after 78 days? So first thing I want to do is start by using the initial amount. So I want to use the initial amount that they gave us. So they tell us that initially there was 300 milligrams, and I don't know what the C value is, so I'm going to put down a C. E is an exponential base. I don't know what the K is, but the initial amount we're going to assume T is equal to 0. Alright. So what this happens is that since t is equal to 0, this all just becomes 1. So my C value is equal to 300. Now, that's going to be one of the unknown constants I have to solve for. The other one I have to solve is the K, the constant of proportionality. And that's where the half-life comes in. So I want to use the fact that the half-life is 65 days. So what that means is I have 1/2 of the initial amount at 65 days. So I have 150 milligrams when the time is going to equal 65 days. So the C is going to be 300. E still is the exponential base. I don't know what K is. That's what I'm going to be solving for. But I know that the time is going to be 65. Now each one of these scenarios is going to have a different half-life, or each one of these elements will have a different half-life. So you're going to use this information to help you solve for the K value. Alright, so go ahead and solving this. I'm going to divide both sides by 300. So it's going to give me 150 over 300. And that's going to be equal to E to the K times 65. I go ahead and reduce this. 150 divided by 300 is going to give me 1/2. So I can say that 1/2 is equal to E to the K times 65. And then to undo the exponential base, I'm going to take ln to both sides. So it's going to be ln of 1/2 equal to the ln of E to the K times 65. The ln and the E cancel off, so this undoes that, and I end up with ln of 1/2. So let me put that back in the correct color I was using. ln of 1/2 is equal to 65 K. The last thing I want to do is I want to solve for K, so I want to divide both sides by 65. And I do have to punch this up on a graphing calculator. So when I do punch this up, I have this already solved out. So my K value is going to be, the answer that I got is negative 0.0107. Now this is a value that you want to have stored, so you want to make sure that you take this value, and it's fine that if you approximate it or round it off as you're working, but you want to have this stored value in your graphing calculator when you guys are using it. So okay, so now that I have my K value, I can come up with my my equation. My equation is going to be y equal to the initial amount, which was 300, e to the negative 0.01 0.0107 t. Now, what the problem was asking initially was they wanted us to figure out how much was the amount that was remaining after 78 days. So really, what I have to do now is take 78 and plug it in here for t. So they just want you to evaluate this at 78. So y of 78. Now I've already plugged this into my calculator and gotten the answer. So you have to punch this up into your graphing calculator, and you should end up with 130.582, and the units of measurement was milligrams. So the answer is going to be in milligrams, and that's the answer for part A. So again, I plugged in 78 into t once I got my equation solved for. Now for part B, they want to figure out how long will it take for the mass to be reduced down to 15 milligrams. So you want to figure out how long it's going to take for this equation to equal. Figure out how long it's going to take for this equation to equal 15 milligrams. So you set this equation equal to 15, and then you solve for it. So what I'll go ahead and do over here is I'll take my equation that I found, set it equal to 15, and then solve for it. So it's going to be 15 equal to 300 e to the negative 0.0107 t. And then go ahead and solving it. I'm just going to go ahead and divide both sides by 300. So dividing this by 300. And this reduces to 1 over 20. So I can say 1 over 20 is equal to e to the negative 0.0107 t. I go ahead and take ln of both sides, so it's going to be the ln of 1 over 20 equal to the ln of e to the negative 0.0107 t. This goes ahead and cancels out the ln and the e, so I have ln of 1 over 20 equal to negative 0.0107 t. Go ahead and divide both sides by this. Now when you guys are going to divide both sides by this, you basically have to take ln of 1 over 20 divided by this k constant. Make sure you use the k constant that you found as a stored value. So even though I'm using this number, this decimal, I'm really plugging it into my calculator as the stored value that I found up here for my solution. So when you're dividing both sides, when you divide by this this k, my solution is going to be 280.925 years, and that's the answer for part B. As far as how long it's going to take for the mass to be reduced to 15 milligrams is 280.925 years. And so that's the video.